Next problem. A storekeeper wanted to buy a large quantity of light bulbs from two brands labeled 1 and 2. He bought 100 bulbs from each brand and found by testing that brand 1 had mean lifetime of 1120 hours and the standard deviation of 75 hours, and the brand 2 had mean lifetime of 1062 hours and standard deviation of 82 hours. Examine whether the difference of means is significant. So given clearly the size is taking 100 bulbs to test, right, on both brand. So size of the samples n1 equal to 100, n2 equal to 100. So mean lifetime, right? So x1 bar 1120, similarly x2 bar 1062, and the standard deviation s1 and s2, s1 equal to 75 and s2 is equal to 82. So he is checking the lifetime of the bulb, right? In first set there are two sets, first set and second set, 1 and 2, right? In 1 the lifetime of the bulb, the total hours, right, is 1120. In the second set is having the mean 1062. So we are asking there is any significant difference between the lifetime of the type 1 or type 2, right? We are going to check that. Defining hypothesis H0, there is no significant difference, both are same, right? And alternate hypothesis, there is a significant difference, they are not equal, right? We are using the two-tail test, right? So significant levels they have not given, that is why we are taking 5%. Test statistics z is equal to x1 bar minus x2 bar by root of s1 square by n1 plus s2 square by n2. Substituting these values, 1120 1062 minus 1062 divided by root of 75 square by 100 plus 82 square by 100. So after simplification you will get 5.2913. So calculated value of z is 5.2913. So 5% level tabulated value we know 1.96. Comparing these two, definitely calculated value 5.2913 is greater than the tabulated value, right? Therefore H0 is rejected. So there is significant difference between the means. So first set and second sets are differ in the lifetime, right? Next problem. A random sample of 1200 men from one state gives the mean pay rupees rupees 400, yeah, per month, with a standard deviation rupees 60, and a random sample of 1000 men from another state gives the mean pay as rupees 500 with standard deviation 80. Clearly they have given two sample size. So first state 1200, that is n1, second state 1000 men, so that is n2. So average pay from the first state, that is sample mean x1 bar is equal to 400, and x2 bar from the second state, the mean pay is 500. Standard deviation from the first state, s1 equal to 60 and s2 is equal to 80, right? So defining hypothesis, there is no significant difference, H0 is, that is mu1 equal to mu2. Alternate hypothesis, there is a significant difference, that means there is no significant difference between the pay, right? That means H1 is there is a significant difference between the pay of the two states, right? That is the hypothesis, right? That is two-tail we are using, right? So level of significance we have you have to take 5%, but they have not given. You can take any level, so this is the standard one, so we are taking, right? Test statistics z is equal to x1 bar minus x2 bar by root of s1 square by n1 plus s2 square by n2. Substituting the values, 400 minus 500 divided by root of 60 square by 1200 plus 80 square by 1000. After simplification you will get minus 32.6152. So taking the modulus value, calculated value is equal to 32.6152, very high, right? Tabulated value we know 1.96, definitely calculated is greater than tabulated, so that is why H0 is rejected. So there is a significant difference between the pay, right? Next problem, two random samples give the following result. So sample 1 and 2 size they have given, that is n1 and n2, right? 12, 10. Mean, sample mean x1 bar 14, x2 bar 15. Then they have given difference of sum of squares, right? That is difference from mean sum of square, right? X minus x bar, right? So 108 and 90. Test whether the samples from the same population, it is from the same population or different population. So H0 is same population, H1 is different population. Given sample size n1 equal to 12 and n2 is equal to 10, I already told you. Similarly, summation x minus x1 bar square equal to 108 and x minus x2 bar square equal to 90. So x1 bar, x2 bar, everything is we know 14, 15. We know s1 square, so here we have to use this formula, right? Note that. In the previous problem also, in the last video, we have used this thing, right? S1 square is equal to summation x minus x1 bar square by n1 minus 1. So 108 by 12 minus 1, so you will get 9.8182. Similarly, so S1 equal to root of 9.8182, that is equal to 3.1334. Similarly, S2 square is equal to summation x minus x2 square by n2 minus 1, not n1. Right? So 90 by 10 minus 1, so you will get 10. So S1 is equal to root 10, that is equal to 3.1623. So defining hypothesis, mu1 equal to mu2, there is no significant difference. Alternate hypothesis, mu1 not equal to mu2, two-tail test. So test statistics, z is equal to x1 bar minus x2 bar by root of s1 square by n1 plus s2 square by n2. Substituting the values, 14 minus 15 divided by root of 9.8182 by 12 plus 10 by 10. So you will get minus 0.7416. So taking modulus value, that is the calculated value, which is equal to 0.7416. Tabulated value of z is at 5% level 1.96. Here conclusion is calculated value 0.7416, definitely less than 1.96, that tabulated value. Therefore, there is no significant difference. So these samples don't have the difference, right? Sample means the population are from the same population. The samples are from the same population. That is the conclusion. Thanks.